now. So now we are live and will be posted to YouTube. Just for full disclosure, get rid of the chat here. All right. So, next class, the idea is that we will have more of a discussion based class again. And unfortunately, we have a lot of lecture material to slog through today. So I'm really just going to try to power through this so we can finish up and concentrate more on discussion. If I finish early and have a little bit of time to have discussion, that's great. But yeah, Washington and Lincoln. Yeah, exactly. Uh, yeah, uh, yeah. President's Day used to be two individual, presidential celebrations. But anyway, yeah. So we are going to really just sort of power through today and try to get through the material, so we can devote next class to more discussion and so bear with me. I do expect this would be unfortunately a bit of a long one, especially seeing how we have the majority of the presentation left to get through. But please stop me and shout out if you have any questions. And if I can, I'll get through early so we can have discussion. But like I said, we have more slides to get through than we got through last class. So we had just left off with Sally, who you recall, and was referenced in Sapolsky's book, sort of made a screw up by stressing out rats in another study that he was trying to do. But in so doing, he found this very interesting phenomenon where actually the stressing out the animals would seem to be producing a very strong effect on a variety of outcomes like ulcers. So he decided to consider stress as a primary independent variable, and conduct a more controlled study to get at the importance of stress. So what he did is he housed rats in cold conditions for 2 days, 2 weeks, or 2 months. After 2 days, he observed hypertrophy of the adrenal cortex, reduced immune cell numbers, atrophy of the thymus, spleen, and lymph nodes, which are all characteristics of a classic stress response, and a relatively prolonged one at that for 2 days. However, after 2 weeks, the rats no longer showed these symptoms. They had become adapted to the stressor. And after 2 months, the rats lost their acquired resistance to the low temperature, and many of them died. So this led to this sort of three-stage model known as the general adaptation syndrome, or three processes of coping with a stressor. The first would be the alarm reaction, where the stressor is detected. I mean, this would be primarily your sympathetic fight or flight response. Then there'd be resistance, or essentially coping with the stressor, something that some of us are better at than others. And I will get into some theories as to why that might be later in the lecture, that I think are very interesting. And then finally, exhaustion, which is due to prolonged exposure to stress hormones. And as Sapolsky said, it's not really running out of bullets. It's more the effect of a constant bombardment of bullets on the system. So here you can see this in a simple graphical format. At first you would have the body initially responding to a stressor, with changes that lower resistance to a number of things. Then you'd see, resistance build up to this response. But if you are continuing, so rather than sort of running out of bullets, as Sally initially thought, it's the constant bombardment of the stress hormones on the system that can, sort of cause some harm to the body. But eventually, hopefully, we will come back to some new level of homeostasis.
I have a quick question.
Yes.
Just out of curiosity, is there any like disorder or phenomenon that occurs out of a resistance to turn on the stress responsor?
Yes, there are a couple. Um, let's see. I sort of feel like Addison's disease would sort of fit that bill. Does anybody recall any information about Addison's from the Sapolsky's book?
Are you asking like, is it, do we recall the instance that it was mentioned?
Yes, or anything about it?
I don't.
Yeah. Let me. I actually have a good cartoon of that. Let me see if I can find it. It's a fun one. I just had a good cartoon on Addison. Let's go here.
Seems like it'd be quite the anomaly
It
to
would be.
encounter.
It would be. Yeah, no, it's uh very rare and not adaptive at all. Uh but I can't find the oh, there it is. Oh, of course that's not. All right, this is taking me too long. But in general, just look up a little blurb on Addison's disease. Is basically a very, as you pointed out, uncommon disorder that occurs when your body doesn't produce enough of certain hormones. So in general, your response would be deficient to a variety of stressors and can result in sort of very odd physiological and psychological responses to stress. Addison's is one, probably one of the more famous examples of that. There are several others that are blanking on me at the moment, but yeah, Addison's disease is one. Um, so, like if you don't have something like Addison's disease, or really the opposite, I guess would be something more like Cushing's, where you're sort of like always under constant bombardment. Most of us exist in this zone of eustress, which would basically be the optimal amount of stress. I mean, again, stress is a normal coping, strategy. It's there to help us survive and thrive in the environment under a variety of environmental conditions. And the body adapted under various environmental and other stressors. So it's makes sense that we've developed systems to this. And of course, as Sobolski gets into, currently, the things that we respond to are sort of different than what our body evolved to respond to. But anyway, it's important to recognize that an optimal amount of stress, a healthy amount of stress, is actually quite good. I mean, it can fuel productivity. It can help us from being eaten from the lion, or whatever the new equivalent of that might be. However, there are two alternatives here: just simply burnout and rust out. I feel that at some point in my life, I have suffered from burnout. It's very difficult to overcome once it's there. So try to maintain these healthy coping strategies to prevent burnout from happening. And I have no idea what rust out feels like. I would very much like to know. Maybe retirement will do that for me. But yeah. So, what is stress? I think that this is a very interesting thing to consider, because, like many things, the more that you consider the definition, the more flaws you find. For example, in my drugs class, we start the year like, what is a drug? You think it'd be very easy to define, but it's not. The same with stress. Sully famously stated that everyone knows what stress is, and nobody knows what it is. Basically meaning that, I know it when I see it, similar to Stewart's famous description of pornography. That, it's pretty hard to define or write down, but I really know it when I see it. Uh, but we will sort of nail down a definition of stress. Just keep in mind that, like many things, the more you think about it, it's more difficult to define and describe, and there's more nuance to these things than a simple sentence can sometimes portray. But our definition of stress in this class is going to be the sum of all non-specific effects of factors that can act on the body to increase energy consumption significantly above some resting level. Many stress responses have adaptive effects. For example, you can have an increased immediate availability of energy brought on by glucocorticoids, adrenaline, that means epinephrine or noradrenaline. You can have increased oxygen intake, which can result from epinephrine. Basically, your respiration is more. There's going to be more oxygen interacting with the blood, carrying out to cells to basically increase function throughout the body. You're going to have decreased blood flow to organs that are not necessary for movement. So there's going to be sort of selective movement of oxygen to the places that you need it most. You'll have an inhibition of energetically expensive processes that are not related to immediate survival, like, for example, sex. And you will have decreased pain perception. Endocannabinoids and endorphins are known to increase during the stress response. Endorphins or beta endorphins, they're the primary agonist for the mu opioid receptor, which opioids also act at, and endocannabinoids, of course, act at the cannabinoid receptors in the brain. You also would have an enhancement of sensory function and memory, although, yeah, we're going to get a little more into the memory thing. It varies a little bit, and part of that depends on how long the stressor lasts and what receptors you're actually acting on with glucocorticoids, but we'll get there. Interestingly, while long-term stress or prolonged stress can impair immune function, acute stress can improve immune function, which you could imagine would have some benefits in, for example, dealing with a ER type stress situation that's brought on out in the public. But here, this is sort of getting back to the way that these effects can also be studied or causally associated. So 1/3 of that equation is removal of the endocrine gland and seeing the function go away. So that's what you can see here, in addition to a correlation between the effect and between the overall effect. So here they exposed animals to an antigene, or basically a sickness, and did it in one group with a sham surgery, meaning sort of a fake surgery. So I mean, is just going through the surgery having an effect, intact adrenal glands, and then those with the adrenal gland removed. And as you can see, if you basically stress out the animal, you can see a heightened immune function response initially relative to non-stress controls in both intact and sham groups, but not without the adrenal cortex. Corticotropin releasing hormone is something we've already gone over. And of course, I want you guys to be aware and able to diagram the corticotropin releasing hormone effect on the pituitary and the adrenal axis with ACTH and cortisol and blah, blah, blah. But in addition to provoking release of ACTH, it also mediates some of the stress response as well. People have been trying to tie down how CRH, often called CRF when you're just talking about the brain, influences behavior and neurotransmission. And quite frankly, the literature is a hot mess, I think in part because of, differences in animal care conditions and how, different things and variables can influence the stress of the animal so much. For example, if you read the dopamine literature, you can find completely contrasting articles from big names in the field, some arguing that CRH increases dopamine, others arguing that it decreases dopamine, but its effects in the amygdala are pretty more, clear at this point. And what's shown is that CRH being released from the hypothalamus not only acts on the pituitary, but can be released and act on areas in the brain, including the amygdala, which mediates the anxiety response or part of the anxiety response. High CRH results in more anxious behavior. The animals will spend more time in closed arms of what's known as a radial arm maze. You will also see impaired spatial learning and memory, possibly more increased or enhanced emotional memory, however. And, that also could be an important component of sort of the deleterious effects of long-term stress on emotional memory and sort of stamping in trauma. But CRH receptor antagonists, by contrast, can reduce anxiety. And this is very important. There are two different kinds of corticosteroid receptors that we're going to get into and use in a variety of examples here. Both respond to corticosteroids. They're the mineralocorticoids, which I'm just going to call MRs from here on out, and the glucocorticoid receptors, which I'm just going to call GR from here on out. The big difference between these two flavors of receptors is what's known as their affinity for corticosteroids. MRs exist in a high affinity state. GRs exist in a low affinity state. So simply what that means is the MRs love corticosteroids. I mean, if one's around, they just hug it up, bind really quickly. The biophysical reaction is very potent. Whereas the GRs are a little more standoffish. They need a lot more corticosteroids to really embrace them. So this results, as you can imagine, in a temporal difference in how these two receptors respond to glucocorticoids or corticosteroids. The MRs respond first, and really can respond to even, diurnal changes or circadian changes in corticosteroids throughout the day. Whereas the GRs come on when you have much longer, higher, prolonged levels of corticosteroids. So, the MRs are more involved in the initial stress response, and the GRs are involved in more sort of the recovery response. Another way of splitting these two would be MRs are sympathetic, or more as what we think of sympathetic, and GRs are more associated with what we think of parasympathetic, rest and digest, versus MRs, fight or flight. And one more important thing that I want to note here is that, both of these receptor types have, similar effects. And by that, I mean, like at the general level, they both can produce immediate changes at the cellular level and also both induce changes in gene expression. However, those cascades and the exact cascades are going to be a little different, as you can imagine, for long-term adaptation. Here's just another simple diagram demonstrating basically what I said previously. The MRs respond first. Existing in a high affinity state, they're going to be more responsive to, lower levels. And this is going to trigger a fight or flight response that's going to be more associated with the sympathetic nervous system. By contrast, GR receptors terminate the stress response. and they're more involved with changes in long-term memory storage and general adaptation, but also promoting rest and digest, or the parasympathetic response. So as I just said, the glucocorticoids act at these two different receptor types, the MRs and the GRs. One of the big differences is that the MRs bind to cortisol with high affinity, meaning that they can be saturated relatively early on during cortisol release, even during normal periods of circadian fluctuation. By contrast, the lower affinity GRs, which need just a lot more cortisol to be activated, are only going to be occupied to a greater extent when cortisol is very high and for a prolonged period of time. Predominant GR activation at high cortisol levels could explain the memory retrieval impairments consistently observed after a stressor or administration of glucocorticoids. In contrast, the retrieval impairment at minimal cortisol levels could be a consequence of insufficient MR occupation. So basically, you need, again, this sort of balance. I mean, we're sort of coming back to this recurring concept of balance. You need some level of MR stimulation to basically develop memory formation of, well, certain kinds of memory formation. But you need, but if there's too much GR activation, you can have impaired memory formation. So again, sort of optimal memory retrieval expected when MRs are occupied, but GRs are not. But you need that sort of healthy balance there. So what happens when you block MRs and GRs? Blocking MRs should impair memory retrieval. Blocking GRs should enhance memory retrieval. Blocking MRs is more prominent, or results in more prominent impairment for emotional rather than neutral memories, or those involved with spatial navigation, associated memories. And a lot of this has to do with expression. The MRs are really not expressed very highly throughout the brain. They're most prominently expressed in nuclei around the ventricle, or the central ventricle in the brain, but they do exist at some level in the amygdala, which is, of course, a region that's critically involved in emotional memory formation. Whereas GRs are expressed throughout the brain, including the hippocampus and frontal cortex, which are more involved in various forms of associative memory and spatial memory formation. Again, there are, as you might recall from another class, there are multiple memory systems in the brain. It's not just the hippocampus being the memory center. The action memories are typically brought on by the basal ganglia. Emotional memories are, involve the amygdala as a node and really a bigger circuit. And, the GRs involved in more spatial memory in the hippocampus and frontal cortex, which is more important for spatial and associative memory. So good news, guys. It's going to get worse as you get older. Yeah, that's sort of a bummer. Well, the first thing here I want to point out is you can see an immunohistochemistry coronal sections up there at the top, with MR expression being predominantly shown here around the ventricles. You can see some minor expression elsewhere. In other cross sections, you can see a little more in the amygdala. But the big point here is that GRs are widespread. So, I mean, you're going to have a more pronounced effect on GR activation over the long term in a variety of systems and processes. So as I was saying, it's going to get worse. Something to look forward to is that, when you're young, you typically have lower levels of cortisol and predominant MR activation with enhanced LTP and good memory. However, as you grow older, you can have chronically high cortisol levels, predominantly more GR activation, decreased LTP, and impaired memory formation. Yeah, basically it all goes downhill around the age of 40. So, but on the bright side, you can also adapt to these effects, and the adaptation is actually quite good. Personally, I enjoy getting older every year, and find the adaptation to be quite calming in a way. So I wanted to touch on endocannabinoids a little bit here, in part because I'm an endocannabinoid researcher, but also because they're important. When glucocorticoids bind to the GR receptors in particular, this results in G protein signaling cascades that induce endocannabinoid production. Endocannabinoids are then released into the synapse where they bind on CB1 receptors, which are more predominantly located on GABAergic terminals, although some exist on glutamatergic terminals as well. It's also been shown that the GABAergic terminals are more sensitive to the endocannabinoids in specific regions like the hippocampus. But this actually inhibits GABA secretion because CB1 is a GI-GO coupled G protein or metabotropic receptor, resulting in decreased GABA disinhibition of norepinephrine secretion and modulation of the stress response. So essentially one idea is that the mellowing effect of cannabis may be part of the generalized stress response. It's just a simple cartoon, showing this. There would be activation of the CB1 receptor, which would actually lead to a reduction in GABA release, an enhancement of noradrenergic inactivity or activity, which could have a multitude of effects on the stress response. And it's also important to note that endogenous opioids are also going to be elevated, like beta endorphin. And I think I touched on this a little here at the end, but you would also have changes in your pain response, which is in part mediated by the periaqueductal gray and mu-opioid receptors within it. But what happens when this goes on for too long? Chronic stress is bad. There are going to be a variety of genetic responses that occur, and the genetic differences in corticosteroid receptor numbers or subtype can dysregulate the normal stress response and provoke inappropriate or pathological stress responses. One key sort of idea here is that the entire system changes, including receptor sensitivity and processing and responses to the activation of the corticosteroid. ACTH is the pituitary hormone most associated with stress, but several others play big roles. And again, it's eventually more how the system responds than the actual chemical being released. Take, for example, prolactin, which is released from the anterior pituitary to suppress reproduction temporarily by acting at multiple sites within the hypothalamus. So under a non-stressful situation, like you see in B, you would have release of prolactin, but basically it is going to have more of a positive effect on the system due to the system's adaptation to the prolactin. When you have just a sort of regular amount of prolactin release, it's going to have a positive effect, meaning that it's going to act on the testes to lead to normal levels of testosterone being released, which are then going to have more of a sort of a normal response to the anterior pituitary and hypothalamus. Under stressful conditions, however, prolactin is going to be released from the anterior pituitary in greater amounts. And the greater amounts is part of the equation, but also the response to the prolactin is another part of the equation. So the prolactin being released in sort of prolonged, heightened amounts is also going to have an effect on the testes, but in this case, it's going to have more of a negative feedback response rather than a positive feedback response, meaning that there's actually going to be, less testosterone having an effect. And this is also going to be at the level of the anterior pituitary and the hypothalamus. So not only is there going to be an altered response to the heightened prolactin at the level of the testis, there is going to be, basically reduced effectiveness to the testosterone at the level of the anterior pituitary and hypothalamus. In addition, there is going to be, a reduction in gonadotropin releasing hormone effect at the level of the hypothalamus. So basically, the big picture here is what I really want to get across, rather than knowing every little bit of these specific diagrams. But in response to the stressful condition, you're not only going to have a greater release of prolactin that is going to produce a ultimately negative feedback association, a negative feedback loop. It's also changing how the system responds, not only to prolactin, but also to testosterone at multiple levels of the system. Just good general examples of positive and negative feedback changes under different physiological and environmental conditions. The stress response in the short term, again, is adaptive. I mean, it's very beneficial. We need it in the cases like Addison's disease. You do not see a regular stress response. And you can look up Addison's and other diseases associated with this to see, the outcomes, which aren't always great. But there are, good therapies and treatment approaches for Addison's. But anyway, ideally, the stress response is initiated by a stressor and then deactivated shortly after the emergency subsides. However, prolonged stress can shift the useful adaptive short-term stress response to a pathological condition that can jeopardize health. Post-traumatic stress disorder is a common one. And you can see sort of a inverse response here with the prolonged stress if your body doesn't come back to like this normal level of homeostasis. Under acute stress, you might see, a shifts occur that would increase storage to energy use. This would be your initial response to increased adrenaline and noradrenaline. However, if those bullets keep flying, you are going to result in fatigue, muscle loss, and could even have diabetes. Increased cardiovascular tone at first is good. You want your heart to respond well to that lion or hearing the gunshot. However, if you're continuously stuck in a den of lions or are continuously hearing gunshots, you might develop hypertension. In the short term, you can have inhibited digestion, long-term ulcers, initially inhibited reproduction, and then unfortunately later isn't increased reproduction. Instead, it's impotence or loss of libido and ovulation, inability to become pregnant. Altered immune function and inflammatory responses in acute stress, which can actually, as we looked at the graph before, increase initially, the very onset. With altered immune function long-term, this can result in basically, again, the stress not causing a change in health, but leading to it. For example, cancer, many viral infections, are augmented by prolonged stress. Also, where you might have enhanced memory in certain types of memory early in the stress response. Long term, you can actually accelerate neurodegeneration during aging with prolonged stress. During prolonged glucocorticoids, as I already mentioned, reproductive function is inhibited. This means that infertile couples experiencing stress from the inability of stress to conceive are escalating the effects of stress on fertility, making it even harder to conceive, One thought with acupuncture, there have been studies showing that acupuncture can have some positive effects on women who want to get pregnant, getting pregnant. And one idea is that you're actually countering the stress response and reducing, the glucocorticoids involved. Yeah, the entire thing can be a bit stressful having been through it. Chronic stress can inhibit growth and repair processes. Here, they are just looking at wound healing in caregivers and controls. And what they found was, basically in people that are having to care for somebody, which can be quite stressful. They actually have an impaired wound healing response initially, in a stressful caregiving scenario. It's also important to note that various factors can influence the stress response. One is the social hierarchy we're in. One thing that is positive to take away from this is that humans don't exist in a single social hierarchy. I mean, in these studies, they're very well controlled, and the monkeys exist in a single social hierarchy. Hopefully, we are not subordinate in every social hierarchy we are in. But the literature shows that in these controlled social hierarchies, the dominant monkey will secrete more glucocorticoids when stressed acutely to this than the subordinate monkey. And subordinate monkeys display resistance to negative feedback, which results in prolonged cortisol responses compared to the dominant monkeys. There are sex differences here, which is interesting. I'm not going to get into it too much, but essentially the social hierarchy in the male group is much more standard. The alpha is always the alpha, the middles are always the middle, and then they pick on the little guy a little bit. And then for the most part, they ignore him and he ignores the other group and just stays down in the corner. The females, the social hierarchy looks a little different. The top three monkeys sort of shift roles a little bit more. And interestingly, they sort of pester the bottom monkey more than the males do. So actually quite sad to see. They're really persistent in going after that subordinate. But the stress response here is, of course, different between the dominant and subordinate monkeys. And again, interestingly, these effects are clearest in the social hierarchy of the males, where you're not sort of seeing the shifting of shared dominance in the females. But the idea is that essentially the system changes in its response. So you're going to have gonadotropin releasing hormone being released from the hypothalamus, for example, in a subordinate that would result in less luteinizing hormone being released from the anterior pituitary. In addition, there is going to be a reduced response to the luteinizing hormone at the level of the testes. And ultimately, there's going to be less testosterone being released in the subordinate versus the dominant sort of alpha. This is fascinating to me, and it's something that I would, if we have time, I'd love to reflect on this more. But your reaction to stress starts in utero. Mothers who undergo extreme stress during the pregnancies have an increased risk for their infants to have lower birth weights, developmental delays, attention deficits, anxiety. It also impairs social behavior, and theoretically might even lead to disorders like schizophrenia. In addition, schizophrenia has also been proposed to be associated with viral infection to the infant, which could also be sort of a secondary response to changes in the mother's immune response and susceptibility to viruses. But anyway, the process of prenatal stress is mediated by the HPA axis. It's thought that stress decreases GRs that are in the hippocampus in their offspring, resulting in impaired negative feedback of the HPA axis in adulthood. And again, if you take out, the adrenal cortex, you eliminate this effect. Again, getting back to this sort of overall theme of like, how can we really get at causality? And how do we, why should we be skeptical of certain studies that are really only showing a correlation, which is unfortunately, I guess, all you can really do in most human studies, creating a big sort of gaping hole in really what we can do in behavioral endocrinology, when you also account for the fact that, rats are different than people. But anyway, the mild stress during infancy can provide stress immunization that blunts stress responses as adults. And by stress immunization, I'm basically referring to the idea of basically learning coping strategies at an early age. And this can be conferred by the mother, or the father, or the parent, through things like, in the case of a rat, licking the baby pup. So here, they measured rats that had high maternal licking and low maternal licking, and then stressed out the pup by removing the dam or the mother from the pup for a period of time, and then measured the post-stress response, and really the responses throughout to ACTH. And what you can see is that if you have the high maternal licking, or sort of the high caring early on, you do not show as high ACTH throughout the stress and post-stress response. The idea is that the gentle stimulation from licking or physical touch can reverse the negative effects of stress and allows the pups to cope with stress better as adults. The licking changes the pup's densities of hippocampal GRs, which again are important in the negative feedback regulatory mechanisms of the HPA axis, the GRs. Severe stress during infancy does the opposite, basically prevents stress immunization. Severely stressed rat pups will not show long-term decreases in food intake and body mass in response to endogenous pro-inflammatory cytokines. Elevated stress responses throughout life can alter stress as a neonate. This in part is associated with epigenetic changes. It's thought that, like, for example, the mother licking the pup early on, or having like skin to skin interaction between a parent and a child, can increase serotonin tone and lead to changes in genetic expression. Essentially, there is this idea that we have these sort of like tightly bound histone complexes, and they can basically unwind or uncoil and be changed. So your genetic expression in adulthood can change. And theoretically, this can even be transferred to offspring or progeny across generations. But I don't expect you to know the complete basis of epigenetics here. Just know that in general, it's thought that the mother or the interaction with the parent early on not only is going to lead to immediate change in neurotransmitter release, but can also change genetic expression that can have profound effects in adulthood and possibly even on one's offspring. Let me see how much time I have. I'd love to. Let me get through this, and then if we have time at the end, well, let's see. Yeah, I better get through this. If we have time on the end, I'd love to throw you guys in breakout rooms to reflect on this a little bit. But, does anybody remember the Harlow studies from developmental psychology, or maybe intro?
Yes.
Yes. Does anybody can give me a summary? Oh, it's fine. I'll do a quick summary. So Harry Harlow, did this famous study where he basically looked at the preference of baby rhesus macaques, I believe it was, to a wire cage that also provided food and nutrients, or a sort of a cuddly, furry, fuzzy, comforting guy without food. And I think most sort of robotic people like me would say, well, of course, the monkey's going to go for the food. But the monkey did not. The baby monkey would rather not have food and rather have sort of the comforting, caring, cuddly creature early on in development. And up here at the top, you can basically see what I was like for the first several months of having my firstborn, at least. And yeah, the skin to skin was amazing. It not only influences the child or the infant animal. In the case of a rat or a dog or a cat, it's going to be licking. Like, you're going to see a correlation between licking behavior and, of course, the stress response later on. And in humans, that sort of skin to skin care can have profound effects on stress, immunization, and also changes in the parent as well. There have been multiple studies here that we're going to talk about, that sort of show these important correlations. In one, they measured salivary cortisol reactivity in infants that were received a diaper change at 1 month after, and by corrected age, basically, they have to know like when the baby was actually born. That just basically means 4 months after birth, because I mean, of course, there's preterm and post-term and all this stuff. But anyway, and in infants at 4 months of age, the parents also completed, actually in the infant's parents, the parents also completed the Swedish Parenthood Stress Questionnaire at 1 month, and a postnatal depression scale at 1 and 4 months. And what they found is that almost continuous skin-to-skin care decreased the infant's cortisol level reactivity in response to handling, but it also had the same effect in mothers. So, again, it's not only benefiting the stress response in the infant, but also the parent that is sort of having the child caring response. Yeah, it's sort of like a fascinating thing. One specific memory that comes to mind is also like thinking of the concordance. Before I had kids, if I got on a plane with an infant, I was like, oh my God, like, this is horrible. Like, this is just going to be the worst flight. I'm pissed. I don't like it. But after having kids and infants, and particularly flying on planes with infants, one memory that comes to mind that happened, a few years ago now, but I remember I was sitting next to a single, like a mother that was traveling by herself with her infant. And, there were just some people behind us that were just being incredibly rude to her, and like, basically, complaining, like, everything. So, I mean, like, before this, I probably would have been one of those people. I don't think I would have been complaining so loud and saying disparaging things to the mother. But anyway, I responded totally differently. Like, probably, before kids and skin to skin care, I probably would have moved seats or done everything that I could to move seats. But instead, I tried to be very nice to the mother, and also basically ripped into the people behind us and let them know that they need to shut up. But yeah, anyway, here's another interesting story done in orphans from Romanian orphanages. You know, during this period of time, Romania was known as a very sort of a harsh place to be an orphan. There were many stories associated with this sort of era of, but few of them good. And interestingly, like in Prague, there's this famous artist that did this sort of illustrative statue of sort of depicting every country For example, in Italy, it was just a series of stereotypes. I mean, in Italy, it was like some soccer crazed person, and various things throughout. And yeah, in Romania, he picked basically a scary vampire looking thing. But these stereotypes run deep and are somewhat based on history. But there was this period in Romania that the orphanages were renowned to not offer much comfort to newborn children. And what's important from this is that there's a critical period. So compared to Canadian-born children that had sort of a loving skin-to-skin care type sort of nurturing situation, if you adopted a child out of a Romanian orphanage before 8 months of age or early on, you could see a pretty comparable effect to these Canadian-born children. However, if the children stayed in the Romanian orphanages for a long period of time, you can see that you actually have longer heightened responses of cortisol and much worse outcomes following the prolonged period of sort of neglect is the idea here. And really a fascinating response of how important the sort of social interaction can be is a very rare concept, well, it's especially rare now in developed nations, but can still occur, is psychosocial dwarfism, which is only seen in humans that are reared in situations with little to no physical contact. And in response to very low social interaction, you can see this occur even if there's adequate nutrition. So this isn't from a lack of food. It also brings back to mind like the Harlow experiment, like it's not so much about the food, the infant or the baby or the child really needs that sort of social interaction. And what happens here is you see disrupted growth hormone release and the absence of tissue responsiveness to exogenous growth hormone. So below here is just a fascinating case study where they found, this young woman here at age of 15.3 years, but the height at a normal range, but basically looked like a 9-year-old. Not only in terms of height, but in terms of pubic hair expression, breast development, and just within 1 month. And I almost found this hard to believe the first time I saw it. But in this case, within 1 month in a hospital and bonding with a caregiver, she grew 2.5 centimeters and started to undergo puberty in just 1 month of bonding with somebody. And again, this had nothing to do with a lack of nutrition. It was a hormonal response in basically having a sort of a caregiver, an interactive person. The stress can impair male sexual behavior by suppressing testosterone. Stress inhibits testosterone production, and low T can reduce both sexual motivation and performance. Release of CRH in the hypothalamus in response to stress is known to activate G protein associated receptors in the ACTH releasing cells in the anterior pituitary, which are then going to go on and activate receptors that stimulate protein kinase A pathway, leading to gene transcription. The CRH receptors have been identified in the testes and ovaries, suggesting that the releasing hormone may also directly inhibit steroid production, really in both sexes. I mean, and let's not forget, women do have androgen as well. I mean, this isn't, it's not like testosterone is only in men. stress is also known to trigger a variety of, bad behaviors, including drug addiction. And here you can actually have a very vicious cycle. So the idea here is that, endogenous opioids are released during stress to inhibit gonadotropin releasing hormone and luteinizing hormone. And both sexual motivation and performance are impaired with long-term opioid users. And half of heroin addicts experience menstrual abnormalities. I mean, I've done a good many drug self-administration studies, and it's very difficult to study, in females. There are numerous studies out there that have tried to make sort of a case that, in certain periods of the what's known in rats as the estrous cycle, which is somewhat related to the menstrual cycle in humans. But in certain stages of the estrous cycle, the rat is more motivated to take drugs than others. But I find it, I don't know, I've tried to do this a little myself, and it's very difficult because the use of the drug can basically completely disrupt the cycle or normal, just patterns of cycling. And not to mention how you have to look for that in the rat is a little stressful as well. You actually, especially if you aren't experienced in it, because you have to go in and do daily lavages or swabs. So yeah, like basically a giant coming in to swab you daily is probably also going to be a stressor, unless it's something that you're very experienced at doing. But anyway, social status and stress-related testosterone suppression, is a correlated thing. Testosterone producing Leydig cells have GRs that appear to be involved in normal processes of cell growth, metabolism, and energy use. When glucocorticoids are elevated chronically, enzymes that normally neutralize glucocorticoids at basal concentrations are overwhelmed and testosterone production is curtailed. Dominant animals have a higher levels of this enzyme in theory to ensure fertility. Again, dominant animals, are much more successful, especially in the wild, in procreation. And like I don't know if you've ever been to Rocky Mountain National Park and seen the elk bugling and basically being territorial, and you tend to see one male elk with a group of female elk, and then a few other male elk at the periphery trying to work up the courage to charge the male elk and try to supplant them as the king of the mountain. And it's really just sort of like a fascinating phenomenon that's very clear in certain species like elk and the chimpanzee, and then it somewhat falls apart in other species of primate, even like the bonobo. So it's complicated, across species, and to make big picture generalizations here. Also, keep in mind that there's more than one social hierarchy that most of us are in. But anyway, stress can also lead to impotence and or premature ejaculation. Normal erection and ejaculation need both the sympathetic and parasympathetic tone. Basically, one aims and the other shoots. Prolonged stress results in increased sympathetic output or adrenaline, epinephrine, which makes it hard to establish a parasympathetic activity in the penis that's necessary for an erection to occur. And the sympathetic responses is what leads to you shooting. So this can lead to premature ejaculation, basically makes you, impotent and trigger happy. There are also very negative issues in females that are exposed to chronic stress. Elevated cortisol can disrupt the timing of the pulses of a variety of hormones related in female reproductive behavior. The entire menstrual cycle can be interrupted, if not just completely stop to occur. In women who diet rigorously or exercise strenuously can have problems with fertility due to negative energy balance. I was actually just watching college gymnastics, this weekend, and I really enjoy gymnastics. I'm really looking forward to the Olympics, but which apparently are happening, which is crazy. But it's not so crazy. I bet most of those people will be able to have vaccines. But one thing that always comes to my mind is as much as I love female gymnastics, it's also somewhat crazy to me how young the girls are, and then it's even crazier when I start to think like none of these girls are probably cycling like at all. I mean, it's just such of a stressful changing thing. I mean, it's really remarkable. But how children respond, right. There are physiological factors in stress and coping. How children responded in a test of one example here is like how children responded in a test of putting their hands in cold water, and how they responded predicted health problems as an adult. Over 70% of those that overreacted to the stressor developed cardiovascular disease, compared with 20% of those that displayed little reaction to the stress 50 years earlier. So again, I mean, I think this goes back to the epigenetic concept that basically your stress immunization can have sort of long-term effects on genetic expression and how you respond and react and cope later. Some of us, I think, would be better on the front lines in the military situation than others. And some of that probably has a lot to do with initial stress immunization. But here in another example, they deprived two monkeys of food, but fed one a non-nutritive flavored placebo. And only the first monkey displayed elevated glucocorticoids, suggesting that the placebo monkey did not perceive things to be as stressful as the other one. The main psychological factors in modulating the stress response are essentially trying to be able to feeling control over the situation, being able to predict its occurrence of the stressful situation, like being able to tell when a test is going to happen. Is it going to be a lot less stressful than a pop test, for example? Knowing when you're going to participate in an athletic event, or knowing when you might be engaged in a conflict, is going to be a lot less stressful than being ambushed. And then there are outlets for dealing with the frustration, which are very important. I think last time we reflected a little bit on healthy coping mechanisms. I don't think that this is something that's emphasized enough in our society. But yeah, it's just something that I feel like I was not taught early on, throughout education, throughout school. I mean, my PE classes never focused on this. But how do you deal with stress and frustration? I probably got great A-level grades of negative coping throughout college myself, and it wasn't really until later in life that I've learned positive coping approaches. But yeah, like going out and drinking on the weekend, for example, might feel really good the first time you do it, but that sort of negative coping approach is going to catch up with you. Same with fighting. I mean, another typical one, like you want to go and just have outbursts on somebody. And interestingly, there's studies that show that at least some animals will work harder or show greater motivation to aggress on a subordinate than they will even to take cocaine. So let's not pretend that it doesn't feel good to just completely aggress on somebody, especially if you think you win. But you know, again, like that isn't really going to be a healthy long-term coping approach. And habituation, basically, you know, this involves a lot of the GRs and sort of long-term adaptation, physiological adaptation, and how well you can habituate is influenced by a variety of factors, including your genes and early life experiences. Control and predictability are key. Being able to control a stressful situation is basically a type of coping behavior. In animal studies, if there's a warning signal before a shock, it reduces the glucocorticoid concentrations to that shock in comparison to trials in which a warning signal did not occur. You know, outlets, having a way to sort of displace the behavior. In rats that receive shocks, there are lower glucocorticoids that they can chew on a piece of wood or attack another rat. In humans, the effects of stress can be ameliorated by engaging in a hobby or healthy exercise. And again, you know, attacking someone else isn't really a long-term positive way. You know, that will catch up with you, it turns out. Uh, in children, and quite frankly, me, leg swaying or foot tapping is still quite common. When I was a college student, it was very common that during a sort of a stressful lecture where I felt like the chemistry was getting a little too hard, you know, you could see me shaking or swaying my legs throughout the lecture, which I now recognize in hindsight was basically displacement. Habituation, learning that a stimulus that was originally perceived as a stressor is not a stressor. A good example here is squirrels on campus. You know, the squirrels on campus probably, well, who knows these days? But at one point, when you used to go to campus, you know, you might have noticed that squirrels and geese weren't that scared of you. They would be walking right along the sidewalk with you, maybe even coming up to you because some other student before them gave them food. You know, paratroopers jumping out of a plane is another good example. You know, the first time you do that, it's pretty scary. You know, after a few times, you know, you can actually learn to enjoy it even. And then how well you are able to habituate can be influenced by a variety of factors as well. You know, as I've already alluded to, stress can enhance and maintain substance abuse. Glucocorticoids accentuate the effects of dopamine to increase the rewarding properties of drugs. A finding that's actually somewhat controversial in the literature, but you know, let's just go with the one side of the story that supports that. In fact, glucocorticoids on their own have reinforcing properties in rats and have been reported to produce feelings of euphoria in some human studies. Stressful stimuli can also increase propensity to self-administer drugs, and that's pretty well documented and common across labs. You know, and can reinstate drug self-administration that has been extinguished. And this is thought to be a model of, you know, craving in human addicts. So basically, you know, the recovering alcoholic or recovering heroin addict that has been, you know, drug free or teetotal for, you know, a matter of months, if not years. You know, basically, right, you know, gets their significant other breaks up with them, they lose their job, and a pandemic hits. You know, the propensity of them turning to the bottle or going back to their, you know, negative coping approach or drug addiction, you know, basically skyrockets. It's a very dangerous time for such a person. Both alcohol and stress can induce the hypothalamus to produce and release CRH. CRH stimulates the release of beta endorphin, which also acts on opioid receptors in the brain. These things can also be altered differentially throughout the withdrawal process in a very complicated way. Here, this is sort of relating these concepts together back to subordinate versus dominant monkeys. This is work from the Nader Lab. My wife was involved in some of this work, but essentially what they found was that subordinate monkeys showed a reduced response to dopamine. They basically had lower levels of a dopamine D2 receptor in the brain already. And then they also took a lot more cocaine than dominant monkeys. As I already alluded to, this was very clear in the male animals and was not so clear in the female animals, in part because of how the social hierarchies are different in the sexes in the rhesus macaques. All right, so we have 4 minutes left, but I made it through everything, so we can have nice discussion next class. Anybody have any questions? I particularly would love to pick anybody's brain on their thoughts, involving Harlow. Does it resonate with you? Can you think of examples of, sort of the parental interaction? And also, I mean, like sex differences are an interesting thing here to think about, in a variety of ways. Especially in our society versus others, and generational changes that are happening rapidly in between, for example, sexes and parental care. Thoughts?
Well, I do wonder with sexes and parental care, often with male children, I think they may get less cuddle time than a female child. Not maybe like when they're babies, but as they get bigger, I think, first of all, a lot of male children are really active. Some females are, but male children often are more active. So, and I think socially, it's more acceptable for women to kind of sit down and cuddle and read a book than often it is for male children. So maybe they won't get the same, cuddle time rewards as female children would get, and that could affect them mentally or psychologically.
Yeah, fascinating thought. I mean, a lot of controversial responses are possible there. Right, and not to mention how parents view these things is changing, but also it's different in different societies. In sort of the multicultural US, you're going to see a lot of variability, and also in socioeconomic places and regions. I think a lot of the stereotypes in there would be very true, like where I grew up in South Carolina, but aren't necessarily true in my household now. So it's a fascinating one. And employers, and as a society, I think we could do a lot better with this. I would say that one of my employers or bosses, when I had my first child, I got a better parental leave situation than my wife. During that one, and my wife didn't get a horrible one either compared to what a lot of people get. She was working for the Army, and they gave her probably 2 or 3 months, maybe I think 10 weeks. But I got more. I got better pay, full pay during that period, whereas I think she had a slight reduction. And my boss at the time, who was a good father himself, essentially said, I know you're going to want to keep pursuing your career. You can do that from home, but I got to tell you, if I see you around here, I'm going to be pissed. Like your job now is to basically bond with your newborn. You need to do skin to skin. You need to do this, you need to do that. Whereas I also had a boss at one point that basically tried to dissuade me from ever having children, and said just horrible things about children all the time. So yeah, like there's tremendous variability out there, but yeah, I agree with you. Like social acceptance, especially trying to break down some of these sort of stereotypical things about the father being very active in the process. It can't hurt. Yeah, but yeah, like, and then some of it could be like pure biological. It's and like you said, I mean, like my son, case study of two, but my son is a lot more physical than my daughter. Although I wouldn't say that I saw that so much when they were so young. It's just like now my son just always wants to wrestle and fight, and my daughter doesn't want to. She wants to do that a little bit, but not quite to the same extent. Uh, but that's also just a case study of two. Let me actually stop recording here.
I had a